Say we are pulling an object. Problem 2. We are pulling an object or pushing an object. Let me just put it for pulling an object like this. This problem is similar to if I do like this. So, not much difference if I bring this like this or if I go like this. The only difference is the way that the force is directed, but the problem is the same. Let's say that the object is 10 kilograms. The mass is 10 kilograms. It's on the surface. You apply the force of, let's say, 40 Newton or 20 Newton. 20 Newton, doesn't matter. At an angle 30 degrees. Well, let's use 37. Okay, so the question, find the acceleration. As I said, whenever you are looking for a particular force or acceleration, usually you will apply the Newton's law of motion. This is a case. What we are looking for? Acceleration, but we don't have anything on kinematics to find the acceleration. There are only two ways so far in physics that you can find the acceleration. One, if I give something related to kinematics, position, velocity, the big three, something. But I didn't give anything. So the other way have to be applying the Newton law. Two ways. I want to find the acceleration. B, I want to find the normal force on the object. So, the first thing, what did I say going through the steps? What will be the, I set it up already, pretty much. What will be the second step? I draw, before the free body diagram, the row diagram, which is simpler, then the free body diagram. So, what forces, in addition to these forces, appears or are acting on the object? Normal force. How do you graph normal force? Upward, perpendicular to the surface. And always from the point of application. This is the point of application of this force. This is the point of application of this force. What other force is acting? Gravity. Gravity always acts on the center of gravity of the object, which is pretty much the center. This is a row diagram. Step number 2. Step number 3, assuming that there is no friction. For now, I leave the friction away from the picture. What will be the step number 3? Free body diagram. In which direction is moving? To the right. What is my positive direction? To the right. If it was moving to the left, my positive direction will be to the left. In dynamics. This and this, and now the object, the force, I will put now all forces from the origin. Normal force, Fg. This is my row diagram. It's still not a free body diagram. In the free body diagram, I want to include up to when I am an expert. When you will be an expert, I mean, you save time. But when you are just starting, draw the components. Fx and what else? Fy. This is a free body diagram. Now you can visualize better what is going on along x and along y. Next step. So you can see step number 1, step number 2, step number 3. We go to step number 4. What did I say in number 4? Which Newton law we will use and along which axis? We are looking for the acceleration. So along which axis is the acceleration? Everybody can see that this object is accelerating along x. So which Newton law, if you are looking for the acceleration? Second law. Sigma F along x equal to ma. This is the step number 4. Which Newton law and along which axis? When you are an expert, omit that step. Step number 5. Critical. What is the net force? What is the algebraical addition of all forces along x? You go to the free body diagram, which we draw for a reason. We are not Picasso and Salvador Dali. We draw for a reason. It's not for a beauty. It's to help in this step. What is the net force you see, or what is the forces, addition of 4 forces along x? Yes, Fx. That's it. You cannot invent any forces. If they are not there, they are not there. Along x. So you cannot say Fx plus